Hi, so in this video, we are going to go through and talk about how you actually run a method controlling both the LC and the MS of the Q-Exactive Plus together using a feature of XCalibur, which allows you to define an instrument method. And so basically you're automating a protocol that the instrument will manually run so that you can set up your acquisition queue and just have multiple samples running at one time. So to do that, there's a couple of different ways that you can do it. Probably the easiest way if you're just starting is to go into your instrument setup, which, as I mentioned in the last video, these can be kind of slow. So let's maximize this. Okay, so in our instrument setup, it's basically going to walk you through anything that you want to set as parameters to run your specific method. If you go in and modify a method, this will look a little bit differently, and in later videos we can go through how that actually happens. But if you're setting up something for the first time, this is where you would start. I am going to set up a method where I'm going to do direct infusion using the Hesse source. So we're actually not even going to use the LC, although I'll walk you through how you set this up because we're going to have to go through the protocol anyway. That's going to be used by the chemistry department to look at whether or not a cofactor has bound to one of their proteins. And so one of the first things that you need to set, so currently you see there's two different buttons right here, right? So this top one is the Thermo SII. This is our Ultimate 3000. And so it's going to walk me through initially all of the parameters that I need to do to set up the Ultimate 3000. And then once I'm done with that, then I'll go in and actually set the parameters for the Q-Exactive. Because we're only injecting one protein in, this is going to be a really short run. So most of the runs that we do are anywhere from 30 minutes to 150 minutes, which is more typical if you're doing top-down proteomics. Because we're just looking at one protein, it's not going to take very long to infuse it in. We're actually going to be using the syringe. And so this is only going to be 5 minutes long. If you look down here, this tells you basically what kind of parameters that are going to be recorded from the LC. So you can have your column oven temperature, your loading pump pressure, your flow rates for the right, left block, and then total NC pump, and then your NC pump pressure. Normally, again, the only things that are going to be really important when you're running a sample is to look at the pump pressures to make sure that you're getting there's no like weird leaks or anything that are happening. So usually the only ones I keep selected would be the NC pump pressure and the loading pump pressure. But again, because we're not using the LC, I don't need any of this information. So I'm going to deselect all channels and go on to the next one. These are your general settings for your loading pump, right? So as I talked about before, we have our different solvents for our loading buffer. I can set this and tell it that A is going to be 2% acetonitrile. They're all the same, and so as long as you know what they are, you could fill this in if you wanted to be a little bit clearer and have this information for later. This is in my lab notebook, so I don't need to put it here. In terms of the pressure limits, I also don't need to adjust anything on that. So again, I'm just going to go to the next page. This is the flow gradient for the loading pump. And so this is specifically referring to if I wanted to change the concentrations of A, B, or C, which are all solvent lines that are all connected into my loading solvent. So by default, usually we only use %A. This is the change in time, right? And so if I wanted to increase the flow rate, what I would need to do is insert a row, change this to 0.001, And this is gonna turn my pump on at a flow rate of, let's just do 2 microliters per minute. We don't need any %B or any %C. And so basically what this would do, I would also need to change this one, is it will increase my flow rate over the course of the method to 2 microliters per minute. I could change this to 5, which is normally what we run our loading pump at. So you can see again, you have your percentage of A, your flow. I don't know why it's not showing up, but usually you'll have like a little line showing you what your flow rate is as it increases. But again, because we're not using this, we don't really need it. One of the annoying things about setting this up is that it does require that you have basically like every instance accounted for. And so if you're going to switch, you need to like, so let's say I went up to 5 here and then I wanted to go back down, I'd have to add in like 2 more rows to adjust for that. So again, because we're not using this, not really necessary. Now we're gonna go and do the settings for our nano pump. And again, you could put in what your different solvents are. So I could put in that my A was 100% water if I wanted to, and that my B was 80% acetonitrile if I wanted to. But because we're not using this, none of that information is really going to be necessary, but we can do it anyway. And so if you were going to do a gradient, this is where you would actually want to set that up. And so let's insert a couple of rows here. And so I can kind of show you what this might look like. So if I wanted to increase the flow to 300 nanoliters, which is typically what we run at, and we usually do this at around 4% B. Right now what's happening is you can see that my %B is going to increase to 4%. This is my flow rate. And because I haven't specified anything that happens at 5 minutes, basically it's slowly going to decline over the course of that 5-minute period. If I add in another row and let's say I put in 4.5 as the time and my flow rate is again 0.3, you can see that this line has stabilized. I could increase this to let's say 10 or 19% B, and you can see that this would be a gradient, right? So you're slowly increasing B to 4.5 minutes, and then eventually you're going back to, we'd want to set this for 4. Usually your equilibration phase, so you can see I got an error message there because things were not consistent. Usually you always have 4% running, and typically with an LC, you'll let this equilibrate for probably 5 minutes with it just running normal before you actually start the gradient. We're not running this, so it doesn't really matter, but because I always have my LC pump on, I want to make sure that it stays on and keeps running my 4% acetonitrile through the whole time. And so I'm going to set this up like this, right? So my NC pump will stay on. It will stay at this flow rate, and it's pumping this % of B through, and the rest of it is going to be A. In terms of these parameters, you can change this. This is for the Autosampler. And so in the Autosampler, you have tiny little vials that contain your sample. You can change how quickly the sample is drawn up, how quickly it's dispensed, whether or not there's a delay. The real things that are probably important here are the sample height and the puncture depth. And so the sample height tells you how much fluid you have off the bottom of the vial, whereas the puncture depth tells you how far the needle can go down. And so if you were to change vials or different types of containers and you didn't change these parameters, basically what's going to happen is you're going to have your needle that's picking up the sample smashing into the bottom if you put it too far down. of your jar, and that's going to damage it, and then you're going to have somebody come out and replace it for you. So paying attention to these are important. There's parameters in the manual of how to change this. Again, we're not picking up a sample, so none of this really applies for right now, but those two parameters are very important when setting up a method. Injection mode, again, this is if we were using the Autosampler, which we are not going to be in this case, but you have multiple different options. You have different size sample loops that you can hook up to the Autosampler. The one that's on our instrument is a 20 microliter, but you can have a 1 microliter, you can have much bigger ones. And basically this is just the volume that is filled into that tube when your sample is being injected. You might only put a microliter of your sample in, and then the rest of what's going to fill that up is going to be your loading buffer. For doing small samples, the technicians have told me that the microliter pickup is the most accurate. And so what happens is it'll pick up a microliter of your sample, or I should say it's the most repeatable if you're doing multiple injections, that you're going to get basically the same amount every time. And so this means that it would pick up 1 microliter or whatever volume I specify it to, and then pick it up first, and the remainder of that will get filled in with the loading buffer. If I do full loop, this would fill the entire loop. So if it's a 20 microliter, it'd pick up 20 microliters of my sample, or partial, which I think works up similar to milliliter pickup, but you'd have to look that up. This asks you which device it's connected to. So our loading pump is where we have our loading buffer. You can have it rinse between re-injections, so that just kind of cleans out the system if you wanted to. The other important part here is your transport vials. And so you have in the Autosampler, if you were using this, a tiny little vial that's contained with loading buffer. And when this microliter picks up 1 microliter of your sample, it then goes over to this transport vial in a position that you've specified in the Autosampler and picks up the remaining amount of loading buffer. If you have the wrong vial space specified, or your vial's in a different spot, your method won't run. And if there's nothing in here, your sample won't load onto the column, or you won't really have any separation, because basically what would be happening is instead of picking up 19 microliters of loading buffer, you're picking up 19 microliters of air. And so you're introducing bubbles into your system, which is never good for LC. Again, you can also change these parameters. These are going to be specific to which type of vial you have in there. So that's just something to pay attention to. If you wanted to use temperature control, so again, this is for the Autosampler, we have it set at 4 degrees so that it keeps those samples refrigerated if we were using them. I have samples in there, so I want to keep that. This is the general settings for the column oven. Again, we have this set to maintain at 35 degrees. You can also set lower and upper bounds here. By default, it goes to 20 as the lower and 45 as the higher. If you wanted to be a little bit more stringent of this, you could not let it drop below 30 and let's say not go above 40. And that would keep your column oven a little bit more stable. If the column door is closed, usually you have very little variation in the column oven. So those upper and lower limits should never be a problem unless there's something wrong with the heating unit and it's going to go too high and then it will shut itself off. This is important. Again, we talked about in the last video how you have the valves that are going to control what is in line and what is being fed onto the mass spec, okay? And so you have a 10-port valve. When it's in the 1-2 position, that's when you're going to have solvents coming from the nano pump directly into the column and spraying into the mass spec. So no sample can get in there. And then if it's in the 10, and so then what's happening is your sample loop is being filled with loading buffer from the loading pump and just directly going to waste if the pump is on. If you switch it into the 10-1 position, that's going to put the Autosampler in line. In our case, the trap column in line, because that's how we have our LC set up. And so that would mean that solvent is going from the loading pump into the Autosampler, picking up our sample, going through the track column, moving on to the analytical column, which is also having your solvent A and B. So you need to set which valves are going to be in which position. Typically what will happen is you'll have your initial time, they'll be in the 1-2 position. So as you're loading sample, some of the junk that's in there is just going to go to waste. And then after that 5-minute equilibration portion of your run, then you would switch the valves. So I'd add in another one that would say maybe this method only goes to 5 minutes, so it's not going to let me go past like 4, but then I could have this switch to the 10-1 position. And so this is telling the computer at this time, switch my valves for me, okay? Again, I don't need this, so I'm going to remove it. But you have to do set which position it's in, at least for the initial time. Once you've gone through that, it's gonna ask you or tell you that you've created all the data that you need and hit finish. If there's a problem, it will tell you. And then you're gonna come up into this, which is your kind of like normal overview. So you have your loading pump settings, which it asks you to enter in, your loading pump flow gradient, the NC pump parameters and flow gradient that we set, all of the parameters, so the general settings for the sampler, the injection mode for the sampler, the temperature control for the sampler. When we move to our column oven, again, we tell it to temperature control, we tell it which valves to do, and the general system settings is just how long it's going to be and which of these parameters we're going to save. There are ways to modify the system setup and shut down. So I could tell it on startup to go through and flush the pump. When it shuts down, to go through and get rid of kind of everything that's on there, and then basically set all of the parameters back to what I want to. There are in some cases advanced settings for some of these, and so you can go through and modify like what you actually want to happen. I just leave them as normal. And then you can also have this script editor version, which basically goes through and tells you, so at the initial time, this is every single thing that's going to be happening in the instrument. As we go to 0.001, I didn't change anything, but so these were all those settings that I put in. And then what I want to do is check my method. You can see that my method editor validation results were successful, which means that this method controlling the LC would work, which is a good thing. Now what we need to do is set up our the Q-Exactive, so the mass spec part. So we have a couple of different things here. When I'm setting up a method, typically because I have more advanced parameters that I'd like to set than what the instrument lets me, I change my user role to advanced. If you look here, you have global lists. So these are basically just some of the different parameters you can change over here. I don't really worry about that. In terms of tune files, so remember the Q-Exactive is controlled by tune, and tune is that separate program. So XCalibur has the capacity of controlling tune. It needs to know which file you need to run them. And so some of the things that are important here, we can change this. So one thing is we need to change what our method duration is, right? So we're only going to be running this program for 5 minutes. And so if I change this, it's going to change it to 5 minutes. I'm going to use a program that, or data that was going to be I'm going to be using a protocol for direct infusion SIM that will be used by one of the other labs. And so I'm going to be going through and reading actually what's in this paper. I know this isn't like the best quality of video we've got here, but it's looking at a fast method for just looking at protein quantification. And it does this using direct infusion SIM using the HESI source, okay? And so while we're going through this, I may be looking at some of these parameters that I need to adjust. Sometimes you'll want to adjust the chromatographic peak width. When we're doing some of our protein samples, we might set this to 15 seconds, and we'll do dynamic exclusion of 10 ppm. This has to do with kind of getting rid of or making sure that you're only sampling certain peaks every once in a while, and then kind of ignoring everything else that's around there. What you do need to change here is you need to load your base tune file, right? And so you can see that I had this red dot. If I click over here, this window is going to come up. And for some reason, my tune files are not, oh, here we go. So they're in my methods in XCalibur. So if you remember when we were going through the tune, that we had our different parameters, I may go through and modify these as we start, but I think for the base tune, we're just gonna load the HESI calibration. So now this has a set of parameters that it knows to load. In terms of external hard drive, we are going to be using the syringe. I've actually never used this before. Oh, okay. So I can set this at a particular flow rate. And so in this paper, they used 5 microliters per minute. Our syringe is a Hamilton, and it is 500 microliters in volume. And I'm going to change this so that when this program starts, the syringe is on, right? And so I have set this. If you want to use the divert valves, you can also set those here, or you have your contact closure. I don't use those normally. You don't need to worry about chromatogram, and then your scan groups will kind of set on that. So that's basically just telling the program that you're going to run some sort of tune file with some basic parameters and how long it's going to be. Now what we need to do is set the parameters and tell it what kind of MS we want to do. And so the multiple options we have, you have full MS, SIM, AIF, full MS, AIF, the full MS with the MS2 top N. So this is normally what we use. You can do targeted SIM. What we're going to be doing today is the targeted SIM with the fragmentation, okay? And so once I drag that over to here, you can actually add in, if I were to decrease the length of this, so if I had my runtime, let's say be 3 minutes, oops. I could then add in a different type of MS somehow that would allow me to finish the remainder of the run, okay? And so one of the huge things that you need to keep in mind here, because it's for some reason like very finicky, we set the method duration time for 5 minutes here. You also need to make sure that the general runtime here is set. And so now you can see that my scan groups, what it's going to be doing for the entire duration of my 5-minute method is running this targeted SIM with the MS2. And so now what I need to do is go through and set my particular parameters for this. And so I'm going to do positive ion, and my runtime is 5 minutes. I don't need to worry about any of this for right now. I'm going to use the resolution of 70,000 for my full SIM. My ACG target in this paper, they used 3e⁶. So I'm going to go through and change this. They did 120 microseconds. So this is allowing a little bit longer for the sample to get injected in. And so what this just means, which I kind of skipped over, so basically this is how much resolution you want to get. The ACG target is how many ions you're going to be shooting into your collision cell, and then the IT is how long it takes. If you click on any of these different parameters, you can see that there will be a small description down here at the bottom, which can be useful. Oh, actually, so we're gonna decrease the resolution a little bit. We're gonna change this to 35,000. We're gonna leave all of these the same for now. And gonna increase our resolution here. Decrease the number of ions and increase our injection time. And leave our loop. I'm going to change the isolation window down to 2. And so basically you can go through and change any of these different parameters depending on what is going to be the best for your method. So the other thing that is important is changing your collisional energy. And this is going to be, this is how much energy you're using when you're fragmenting. And so when we run our samples, this paper does the same thing, where they're gonna set this to 27. So now that I have these basic parameters, let's make sure there's nothing else I wanna fix in here. Go into my tune and make sure everything looks okay. I can now go through and save this. And so now what I've done, yeah, see? So I'm missing something. A missing value in my inclusion list is empty. So this is something that I have never done before. Which I'll have to figure out. But basically, just for simplicity's sake here, this is what you would need to do to create a method. And then once you've created your method, if you were going to go run your sample, so let's clear all of these. I could go into instrument method here, browse, and it will pull up all of my methods I have saved. So you can see there's quite a few that I have. You can select which one you want to use and then go ahead and run your sample that way. So hopefully that was helpful.